This is question 22 on chemistry from section 2 of the 2019 BMAT. So we're told that 35 centimeters cubed of a straight chain alkane vapor undergoes complete combustion to form 105 centimeters cubed of carbon dioxide gas. So if both gas volumes were measured at the same temperature and pressure, what is the alkane's molecular formula out of these options? So maybe a good place to begin would be to think about the reaction equation for complete combustion. So what would this be for a general alkane CXHY? So we know we react with some amount of oxygen, and this is going to form an amount of carbon dioxide. How many moles? So that's going to be the same as the number of carbon atoms. So in this case it would be X moles of carbon dioxide, and then some water. The amount of water, although it's not important for this question, would be half the number of hydrogens in this. So that would be Y over 2 waters. And we need to work out the molecular formula of this alkane. And we're given fairly limited information. So just the volumes of the straight chain alkane and the carbon dioxide. We're also told about the temperature and pressure. So what sort of equation should we be thinking of in this context? That's going to be the ideal gas equation, which I always remember as PV equals nRT. Maybe this can be rearranged to a more useful form for this question if we're dealing with volumes. So dividing both sides by pressure leads to V is nRT over P. So what quantity would be useful to work out the alkane's molecular formula? Well, the number of moles of alkanes in this general equation is 1, and the number of moles of carbon dioxide is X. If we can get X, then we can get the molecular formula of this alkane, and so ideally we want to find out this N for carbon dioxide. So how do we do this? We don't know the temperature or the pressure, but we are given two different volumes, and we're told that they're measured at the same temperature and pressure. So what's the best thing to do? Well, if we take a ratio of these two volumes that we're given, so volume of carbon dioxide divided by the volume of the alkane, what is this? 105 divided by 35, or we know it's going to be a nice number, so thinking about the multiples of 35, this is going to be 3. And what does this tell us? Well, we know V is the same as nRT over P, and so this is the same as saying nRT over P for carbon dioxide over nRT over P for the alkane is also 3. What can we cancel out of this equation? So we know they're measured at the same temperature and the same pressure, so these are both constants. R, we know, is always a constant, and so we can get rid of all of these terms, leaving us just with the number of moles of a carbon dioxide over the number of moles of alkane is 3. So if this is the case, if 1 mole of alkane is producing 3 moles of carbon dioxide, then what can we substitute into our equation here? So we know X is going to be 3. Let's make that substitution. So we know there are 3 carbon atoms in this alkane, and that causes the 3 moles of carbon dioxide. And this explains why the volume of the carbon dioxide is 3 times bigger than the volume of the alkane. But this isn't a full answer. We don't know the number of hydrogen atoms, and we're not given any volume information for water. But let's just look at our options. We've got the choice of C3H6 and C3H8. Which one is it? Well, we're told that it's a straight chain alkane, and the formula for straight chain alkanes in general is CXH2X plus 2. This clearly has too few hydrogens. This can only be a cyclopropane or some sort of propene. And we know a straight chain propane molecule is C3H8. So we have our final answer, but for completion, let's just fill in the rest of this equation. We've identified that Y has to be 8, and therefore we're going to produce 4 moles of water. And it turns out this requires 5 moles of oxygen. So our final answer is C3H8. This is the only alkane that can produce this ratio of volumes. And so Our answer on the question paper is D.